Hi everyone, hope all of you are doing well. In this video, we are going to do a hypothesis testing for a population mean when sigma population standard deviation is unknown. Before solving this question, let me remind you about the steps we have in hypothesis testing. Look at here, in step one, we always need to formulate null and alternative hypotheses. Then we need to select a level of significance. Also, we need to take a sample in step 3. In step 4, we need to identify the rejection region clearly. In step 5, I need to calculate a test statistic. If sigma, if sigma population standard deviation is known and we are doing a hypothesis testing for a population mean, I need to find the z value of x bar. But if sigma population standard deviation is unknown, it's not given in the question, I need to find the t value of x bar, by using t students. And in step 6, we need to decide about rejecting or not rejecting the null hypothesis. Okay, so let's go to the question. Look at the question. In this question says the average score of students in a class was 43%. Okay, we have a population of students. The mean of this population is 43%. Okay, some new teaching methods have been applied to improve the class average score. Then they have selected a random sample of 12 students. This random sample of 12 students reported a sample mean of 41.5 and a standard deviation of 1.78. Sample mean x bar is 41.5 and S sample standard deviation is 1.78. Look at here. Sigma population standard deviation is not given here. Sigma population standard deviation is unknown. Now we are going to check if we can conclude that there has been a change in the average score of students at 0.02 significance level. I'm going to test if there has been a change in the average score of students. Look at your question doesn't say if there is a reduction or increase. Okay, so question just says if there has been a change. Okay, so if there is a change in the average score of students, it means the average score is not equal to 43 anymore. So look at here. So in step 1, in hypothesis testing, in step 1, we always need to formulate H0 and H1. Okay, now look at here. I'm testing if there is a change in the average score. When there is a change in the average score, mu is not equal to 43% anymore. Okay, so can it be the null hypothesis? No, because I don't have any equal sign. We must have the equal sign in H0, null hypothesis. So we already have alternative one, H1 here. Okay, so as a result, the null hypothesis H0 would be mu equals to 43. Look at here, I have formulated the null hypothesis and alternative one. That's step 1. So it's step 1. It's step 1 in hypothesis testing. Now in step 2, I need a level of significance. So step 2, I need alpha, level of significance. Level of significance or alpha is 0.02. It's 2% level of risk. Alpha is 0.02. Look at here, just I'm following the steps I showed you at the beginning to make a conclusion about H0. Okay, so step 2 is done. Now step 3. In step 3, I need a sample. Okay, so step 3, I need a sample. Look at here, we have a sample of 12 students. Sample size is 12. Sample mean X bar is 41.5. It's X bar, sample mean. Sample standard deviation S is 1.78. It's the information about the sample. Now in step 4, I need to identify. In step 4, I need to identify the rejection region clearly. So look at H0 and H1 because we have equal sign and not equal sign in step 1 in the null and alternative hypothesis. We have a two-tail test. Okay, we have a two-tail test. So if I draw the distribution of X bar sample mean, it's bell-shaped. Okay, but here because I have a two-tail test, we are going to have a tail on the right side and a tail on the left side. Two rejection region. Tails are rejection region. So the area of the rejection region under the curve is equal to alpha. Alpha is 0.02. So because the total area of the rejection region is 0.02, so I need to divide this number by 2. That would be the area of each tail under the curve. So if you divide 0.02 by 2, you get 0.01. Okay? That's the area of each tail. Okay? Now look at here. I know I'm trying to identify the rejection region clearly. I know I have a two-tail test, two rejection region, one on the right side, another one on the left side. But I need this cutoff point clearly. Look at here, I have a cutoff point here, another cutoff point here. I need to identify this cutoff point, and then I have the rejection region clearly. To find this cutoff point, I need, because here sigma is unknown and I need to work with t distribution. Okay, when sigma is unknown, we are going to work with t distribution. So for a two-tail test, okay, by using t period inverse period two-tail, I can find the cutoff point. Okay, I have made an Excel file for this question. Let's go to the Excel file to find this cutoff point on the left side and on the right side. Okay, look at it. It's the Excel file for the same question. X bar sample mean is 41.5. Population mean, the average score of the students is 43. Alpha is 2%. Sample standard deviation is 1.78. We have a sample size of 12. Let's find the cutoff point for the rejection region by using this function, t period inverse, by using inverse function for a two-tail test. Okay, we already have the function here. This function needs alpha here. Alpha is 0.02 and degree of freedom. Degree of freedom for a T student always is sample size, here 12, sample size minus 1. Okay, it's the cutoff point. I have two cutoff points. The right side, the cutoff point on the right side is positive 2.718 and the cutoff point on the left side is minus 2.718. So the cutoff point on the right side is 2 point, this one, 2.718. If we round to 3 decimal, okay, it's the right one. We have another cutoff point. Look at here. Now we are working with T distribution. Okay, T distribution is zero centered. In the middle, I have 0. On the left side of 0, we have positive numbers. On the left side, on the right side of 0, we have positive numbers. On the left side of 0, we have negative number. So the cutoff point on the left side would be minus this cutoff point, this one. It's minus 2.718. Look at here, and it's decimal point. Now we have identified the rejection region clearly. Step 4 is done. Now step 5. In step 5, I need to find the t-value of x bar by this formula. Because sigma is unknown, we are going to work with t distribution. I need t-value of x bar by this formula. X bar minus mu over s over square root of n. Okay? So x bar is 41.5, mu population mean 43, s is 1.78, and n sample size is 12. Let's go to Excel to find this t-value of x bar. So look at here, look at the t-value formula, x bar minus mu over s over square root of n. Okay, let's find s over square root of n, then we have easier calculation. S is 1.78 divided by square root of n. N is 12. Look at here. Now I have s over square root of n. Just I need to find x bar minus mu divided by s over square root of n. Then we have t-value of x bar. So x bar is 41.5 minus mu 43, mu population mean, divided by s over square root of n. Look at the t-value. It's almost minus 2.92. Okay, minus 2.92 is in the left tail. Okay, look at here. Look at the t-value. Minus 2.92 is in the left tail. Look at it. If I continue the tail, okay, the tail on the left side, if I continue that, minus 2.92, the t-value of x bar is on the left side of the cutoff point. Okay, it's in the tail. It's in the t-value of x bar falls within a rejection region. So now what is the conclusion? We need to reject H0. Okay, so when t-value of x bar falls in the rejection region, we reject H0. Now it's time to make the conclusion. Step 6. So t-value, let me write that for you. T-value falls in the left tail, in the rejection region, in the left tail, or reject region. So we reject H0. Okay, so the H0 that says the population mean is, the average score of the students is 43% is rejected. Okay, so we conclude there has been a change in the average score of the students at this level of significance, 0.02.